So here we go. Integral from a to b of f of x dx. Let's do this in general first. So that for Melissa, you were out on Friday, right? Just bear with me. So I am pretty sure that everybody knows that this definite integral means one thing, and that one thing is
Area.
area bounded by four things. And those four things are, Alejandro?
X equals A.
X equals A.
X equals B.
X equals B. Janaea, finish it off.
Graph of f of x.
The graph of f of x and
X-axis.
the x-axis. So I've got some function f of x. I've got some lower limit x equals A. I've got some upper limit x equals B. And let's say that I want to do n rectangles of equal width. And furthermore, let's say that we're going to focus on the right endpoint method. When it comes to these n rectangles, and we're going to let it go to infinity, we're only going to focus on the right endpoint method for some reasons that we're not going to get into right now. So where do you start? Where would you start? Abel, what would you do?
You want to find your equal width for your rectangles?
So how wide is each rectangle going to be? I love it. How wide?
N.
It would be B, the B minus
That width is B
minus A
B minus A. B minus A is how wide the interval is, and then
divided by N.
divided by n. We're okay with this, right? And then the next thing you're going to do is you're going to chop up your interval. But we have a fancier word than chop up. We're going to use the word
Partition.
partition. Just chop it up, right? Like I would chop celery, chop, 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 chop. Okay, so here we go. Here's A all the way over here. Here's B all the way over here. I've chopped it up. You guys are telling me that delta x is the width of this first rectangle. So this first rectangle starts at A and ends at?
Delta X.
Okay, rather than saying B minus A over N, I'm just going to call this delta x. Delta x is the width, right? So this first endpoint is going to be A plus delta x one time because I've moved over one space. The next one?
A plus 2 delta X.
A plus delta x times 2 because I've moved over that same width two times. Next one?
A plus 3 delta X.
A plus 3 delta x. A plus 4 delta x. It's getting a little messy, I know. But we're going to go all the way out to the final one. And at each of these partitions, up, over, down. Up, over, down. Up, over, down. I'm always using the right endpoint because I'm doing the right endpoint method. There's the nth rectangle. All right, we're going through the general process. So somebody tell me, if I was going to do this approximation, what's the area for the first rectangle? Not underestimate or overestimate. What's the area for the first rectangle? How would you figure it out? Miguel, how would you do the first rectangle?
A plus delta X. F of A plus delta X times A plus delta X.
Kind of close. The question is, how wide is the rectangle? You guys know how wide the rectangle is?
Delta X.
The width is delta x. How tall? How tall, that's where we need the y value, right? I need the y value at the right endpoint, so it's going to be delta x times f of a plus delta x. Are we okay with the first one?
Mm-hmm.
So that's the first rectangle. Janaea, how about the second rectangle?
Delta x
Yeah.
times f of a plus 2 times delta x.
F of a plus 2 delta x is going to be that second one. Salma, how about that third rectangle?
It's gonna be
How wide is the rectangle?
F delta x.
Delta x is the width of the rectangle. How tall?
F of n plus 3 delta x.
Not n
A
plus
plus
3, but a plus 3 times delta x. And we're going to keep on going all the way until I get to the last one, which is going to be delta x times f of a plus n times delta x. And this is what we did on Friday, and we've been doing this before. And then like the big like mind-blowing experience was we started looking at this and we started seeing a pattern, right? What are some patterns that we see with these terms? I'll take anything from anybody. Let's get some hands on this. What do you see? 2 people? 3 people? 4 people? Brianna, what do you see?
I see that the f of a plus the delta x is being multiplied by delta x.
So we're always having an f of a plus some multiple of delta x, right? Other patterns that we're seeing. Fabricio, what else do you see?
We always multiply by delta x.
You're always multiplying by delta x because delta x is the width, right? I'm always adding, right? I've got that pattern happening all the time. And I know before Friday, you guys probably didn't remember, but since Friday, we know that's what big sigma means. Now I'm going to write the sum. The pattern you guys told me is there's always a delta x, right? There's always an f of something, and it's a plus delta x times, on Friday we were calling it I. I stood for,
That's good for the
The initial?
it's the index. It's another way to say counter. My counter starts at 1, and it goes until n, right? And this is that nice closed form of that definite integral. Now, is this exactly the answer for the definite integral?
No.
Think about this one. Is that going to give you the exact answer for the definite integral?
No.
If no, why not? I'm interested in the why not. Somebody tell me why not. Why is this not going to give you the exact answer? Jasmine, why not?
Because you still got that pattern from the right and point method, and it's never exact. It's an estimate because there's an under. Yeah.
Now, there's some underestimate, but I think there's also going to be some overestimate, right? There's some missing area. This is going to be an approximate symbol, right? We're saying that this is your estimate, and I'm sure lots of folks remember how we move from estimate to the exact answer. What do? How do we get the exact value? How do we move from this estimate with n rectangles to the exact value of the definite integral? Brianna, how do you get the exact answer?
Is it to add more rectangles?
You're going to add more rectangles. How many more rectangles do we want?
Infinite.
You want an infinite number of rectangles. And so that's when we're going to write this limit as n approaches infinity. Big sigma, I goes from 1 to n. Delta x is your width, f of a plus delta x times I. Now, just to label all the pieces, this notation here, what do we call it?
Sigma.
Sigma. And sigma means,
Sum.
it means sum, it means to add. The delta x stands for,
Change the width.
the delta x is the width. Okay? Then we also have the a value. That a value, that's not just any random number, that's where you're starting. That's like your left endpoint. Your lower limit of integration. Lower limit of integration. And I, we call that the index. Big picture, is everybody kind of okay? Okay? So here's what I want you guys to do. I want you to see what you can do with this specific example. I'll give you just 2 or 3 minutes. I'm going to take attendance, pass out some papers, read through this problem, show me what you can do. We'll talk in just a few minutes. You can help out your neighbor if you want to. For those of you that don't like helping books, that's fine too. Thank you. Let them dangle. Commit to getting this to me by Wednesday. Jasmine, you want to make corrections for it tomorrow? Jessica, nice job.
That's what I was
So
wondering.
for this one, we assume it's equal width?
Yes. Did it not say equal width?
No, it just says in rectangle.
Equal width rectangles. Sorry. Janaea, if you want to read it. Claudia. Miguel, if you want to read that. Cassandra. Yes, sir.
Like underneath the number line, the definite thing down there.
This guy here?
Yeah, it's equal to the limit. That's the exact value, right?
Right, I'm using equal because we're saying finally when I consider an infinite number of rectangles, that's when I get an exact right answer. Can I borrow a pen?
Like if you have like one, yeah, now you gotta find the segment. It says letting the number rectangle. There's 8 approaches infinity. For which one?
This is the sigma infinity.
Oh yeah, but just use just plug in.
All right, so good news is I didn't see many folks worrying about, oh, but what does this graph of f of x equals 2x squared minus x plus 3 look like? It doesn't matter what the graph looks like. Okay? What matters is where am I starting?
2,
2. Where am I ending?
4.
I'm ending at 4. Other things that matter? How wide's each rectangle? Oh, so awkward.
2
How
over
wide?
n.
Right, it has
1
to
over
be.
n.
It's
2.
the width of the interval divided by the number of rectangles, 2 over n. I'm seeing a lot of folks who are like doing a little number line and they're like, all right, I'm going to go from 2 to 4 and I do my little partition. And for those of you that need to do this, that's great, that's fine, do it. So this first rectangle starts at 2 and ends at?
2 plus 2.
If I'm starting at 2 and that interval has a width of 2 over n, then it must be that I'm ending at 2 plus 2 over n. This next one is 2 plus, you can just turn it off, Jessica. Right, 2 plus 2 over n times 3 and so on all the way out to the last one. All right, I'm seeing some folks that are like, well, then let's do this one rectangle at a time. How wide is the rectangle? How tall is the rectangle? Fabricio, tell me about that first rectangle. How wide, how tall?
2 and 2 over 2 over n.
Yep.
F of 2 plus 2 over n.
Love it. Jessica, how about that second rectangle? How wide is that second rectangle? How tall?
2 over n
2 over n.
times f of 2 plus 2 over n 2.
Right. Each rectangle has the same width. That idea of the same width is really important. Cassandra, do you have a question, or you want to do the third rectangle?
I have a question. Is it supposed to be A, not N?
But A, in general, is our left endpoint. On this interval, we're going from 2 to 4, so we have an actual starting number.
No, I mean about the F of.
The F of what?
The function, it's A of N.
No. A of n is the area, the final area. So A of n is the area that we're going to get. This guy here is F.
It's what we want to find, right?
Right.
A over n.
Right. So, Claudia, how about that third rectangle? I mean, Cassandra, sorry.
2 over N.
2 over n.
F of 2 plus 2 over N times 3.
Times 3. Plus, I go all the way out to the last one, and the last one is this guy right over here. And that has a width of 2 over n, and it's f of, what's the height? For that last rectangle. Careful with that, careful with that. Jasmine, what's the height of that last one?
4.
It's going to be not 4, but f of 4. Right? So I hope everybody sees the pattern. We can collapse that pattern down. And I'm going to say, all right, I'm going to do my sum. What are the things that you see? Let's get some hands on this. What are the patterns that you're seeing in this sum? Solomon, give me one thing.
Wait, it will be equal signs?
Well, this guy here, I understand what you're saying. A of n is the area that we're going to get. We can go with the approximate sign. Okay, patterns that we're seeing in the sum. Fabricio, give me a pattern that you see here.
2 over n.
Okay, 2 over n, that's what I'm multiplying by every single time. What else? Brianna, any other patterns that you see going on here? Okay, you can also write it as f of 2, right, my initial value, plus 2 over n I times, where my counter goes from 1 to n. We're okay? Now, when I was teaching this to the Calculus BC kids before, there are a lot of folks that went straight from this original setup, straight over here, and they didn't write out the areas for all of the rectangles. How many of you guys are kind of feeling like you're there? Feel free. You don't have to do all the little rectangles in between, but it's a good way. So where the equal sign really comes in is at the end when I want to actually write that final definite integral, that final answer. Fabricio, what's it going to look like?
Well, I had a question.
Sure.
For the n on top of the, wouldn't there be 4 instead of n?
No, it's not going to be 4 because n is the number of rectangles.
Oh, okay.
Okay, now let's see what happens though. Because according to Jasmine, I'm supposed to get 4 as the final value that I'm plugging in. If I is equal to n, if I'm at that last rectangle, I'm going to have 2 over n times n, which is 4. Oh, so awkward. That was painful. At the last rectangle, that's what this index means, right? I'm starting at 1, the first, all the way to the last one, which is n. 2 over n times n?
2.
2 plus 2?
4.
4. It's f of 4, just like it's supposed to be. Okay? But to get that final definite integral, what I need to see it's that limit as n approaches infinity. I goes from 1 to n, 2 over n, f of 2 plus 2 over n times I.
Miguel kind of brought this up when he said it, but he said, would you put the infinity on top of the
On top of the sigma?
Yeah, top of the sigma.
No, because we're going to let n approach infinity. So this guy out here, we're just going to say, okay, we're going to find that sum from 1 to n, whatever n is, and we're going to keep letting n get bigger and bigger and bigger and bigger and bigger. There will come a time where I think, Miguel, your question is, can I just write it that way and not write the limit in front? In the world of Calculus 2 and Calculus BC, yes, but for right now, let's just write it that way. Okay, here's what I want to do. I think we've got about 10 minutes before the quiz actually starts. There are some practice problems on the back. Oh, perfect. 9 minutes and 20 seconds. Okay. So on the back, I've given you guys some practice problems where I've given you a definite integral. That means you've got a function, you've got limits of integration. What I want to know is, can you set that up as a sum of an infinite number of rectangles with the right endpoint method? Getting here, I care a lot about. Getting here is what the College Board is going to ask you to be able to do. They're going to say, find this area, set it up as an infinite sum. On Friday, we went into like crazy land of expanding this, properties of sigma notation. As far as I can tell, that is not the level that you'd ever be assessed at. So I just want to focus on, can you set it up? Okay? I'll come around, I'll help out. My solutions are posted in the back if anybody wants to check those. If you just need some calculator practice, you can also find the area for each of these definite integrals. But when the timer goes off, we're going to start the quiz. Feel free to talk to each other and help them out. This is not the quiz yet. Ah. Don't worry, I am confident enough in my organizational skills that I'll put them on the some people call those.
It doesn't matter if I put the
Just call it always correct. Except that's old. You're getting closer. Okay, well at this point I'm just going to take it back.
1 over n. Well, I mean, yeah. Yeah, 1 over n times f of 1 over n times x.
That's n over time. That's the number of rectangles. 1 over n at 0 plus 1 over n. Nice. Yes, sir.
Would we get a point for writing some point for writing that one?
I mean, maybe it's possible. It's anything, right? anything.
Wouldn't
Did you guys ever see the
power
greatest?
forward plus like problem?
Have you guys seen your grades?
Because there's a power.
Have you guys seen your
Oh.
grades? Have you all seen your grades? Okay, how are we doing? Okay, I think you guys are ready.
Okay, so
Yeah, I think.
where you got my phone from?
What happened to
Okay. I don't know, not trying to be hard, but I'm very good at doing this. It's possible I made a mistake. I have no way to just remember the bottom there. I was actually doing this the first. This is the third.
So I know that's good.
Okay. So somebody in the front office.
Yeah, there's someone to talk to you.
Yeah, you usually remember this.
Because you were the only class that I had. All the questions that was yes.
So maybe writing a post-it note about December 3rd.
Do you have a post-it note on your desk?
Of course I do.
we already went over this.
For number one, we have to do, so we're doing it.
Oh my.
So what are the things you know for sure next week? Okay.
That's our script. I don't know how to do this one. Like, you can top one, or no, you're just going to do this whole thing. Yes, do you have your calculator? Like, you can do this one, is that what you're saying? Oh, you don't have to do this whole S? Yeah. Plug in the numbers and even if they're variables, it's still
That's only if it's only I. No. Because you're always getting I. Right? Maybe you're writing it as 1 over n times I or pi over 4n times I. But in that first case, like the 1 over n times I would get plugged into the function. Everywhere there was an x, you replace the x with 1 over n to the I. So here, I over n is being raised to the 4th power. That would tell me that my function x equals 1.
The Carmen?
I think that was up to 20.